Alrighty, so in this video, we are going to look at piecewise functions. The important part to know about piecewise functions is they are a function that's been cut into different pieces, and those pieces have different rules. Right here, they'll have different rules over different intervals of the domain. So what that looks like is we are going to take our domain, and in this case, we broke it into two pieces. This first part is every x value that is less than or equal to -2. So on my domain, we're going to go from negative infinity up to 2, and I can actually be that 2. For this one, this part of my function is saying start at 2, but I'm not equal to 2, and then get bigger, all the x values that are bigger than that. Okay? So when we graph these, I'm going to do the first one in red. This says all the values from negative infinity that stop at 2. So I'm going to do 2 and then the values that are smaller than 2. And the function I'm going to plug them into is this one right here, negative 2x plus 5. So when I plug in the 2, that's going to give me a 1. Plug in the 1, I get a 3. And because this is an x to the first power, every y value should increase by the same amount. Every x went down by 1, y should go up by 2. So let's just double check. 0, yep. So plus 2, this one should be 7. Yep. And 4 plus 5 is 9. And then because we are equal and we have this bracket, when I graph this point, it's going to give me a closed dot. Now let's make a t-chart for my other portion, the other piece. The other piece says start at 2 and x needs to be bigger. 2, 3, 4, 5, 6. I always like to just give myself 5 numbers. The more numbers I have, the more accurate my line or my graph will be. So we're going to take our x values and add 1. So 3, 4, 5, 6, and 7. And this, because we're greater than, when I graph that point, give myself a little reminder, put an open circle. So let's graph these points, and 2, positive 1 should have a closed circle. And then we're going to go 1, 3, 0, 5, negative 1, 7. And there is my line. Boom. And it ends at the 2, but on the other end, this end, it goes on forever because it's going to the left. Now let's graph the one in blue. We're going to start at the point 2, 3. So 2, 3, and when I put a point, it's an open circle because the blue function cannot exist at this point. That's why this is still a function. Red function exists at 2. The blue function does not exist at 2. And then let's plot our other points. 3, 4, 4, 5, 5, 6, 6, 7. And there is my blue function, and it goes on forever. Easy, not so bad, right? Let's try this one again. So what I like to do is I like to look at my restrictions first. What are my pieces? So for this first one, it says x needs to be less than or equal to 0. So less than is going to start at negative infinity and it ends at 0. I can never be negative infinity. Then I ask, Artie, is this allowed to equal 0? And it is. There's my domain for that one. Let's find the domain for this one. Well, this one says x is bigger than 0. So again, start at 0 and then just get bigger without limits. Boom. So when we graph these, we're going to graph x and 2x plus 3. We're going to start with a closed circle, and we are going to go 0, and then all the values need to be smaller than that. And I know they need to be smaller because I'm going from negative infinity. 0 is the biggest. So when I plug in my values, 3, 1, negative 1, negative 6 plus negative 3, negative 8 plus 3, negative 5. Those are my red values. So the first point I'm going to graph is 0, 3, and it gets a closed circle. Negative 1, positive 1, negative 2, negative 1, negative 3, negative 3, negative 4, negative 5. I could do negative 5, negative 7. Boom. And so here is the first part of the first piece of my piecewise function. That's why we call them piecewise. They're made by pieces. And then my next graph, I'm going to do it in blue, plug in x values. Then we're going to take those x values and we're going to plug them into negative x squared plus 3. Well, we want to start with 0 and then get bigger to infinity. Oh, who cares about the Loch Ness Monster? Okay, it's kind of cool. So then negative 1 squared, 1, negative 1 plus 3 is 2, negative 4, negative 1, negative 9, negative 6, negative 16, negative 13. Boom. And because this is x squared, we know we're going to make a parabola, and we don't want to be equal to 0, so we're going to start with an open circle. Well, you'll notice there's already a red closed circle, so what we do is we're going to draw a blue open circle around it. And then 1, 2, 2, negative 1. We're making a parabola because it is x squared, so it's not a line. We're not drawing in a line. We're drawing in half of a parabola. Boom. There we go. Not so bad. What this next group of exercises is having us do is they want us to evaluate the following piecewise function for every given value. So they're saying if I give you an x value of negative 3, what is the y value? Well, what we need to figure out is which of these can I plug the negative 3 into? So if I look at the colors, we can do a red, we can do a blue, and I'm just going to do them red, blue, purple because, frankly, why not? So which of these lets negative 3 happen? Well, right off the bat in red, I see x has to be less than negative 3. It cannot be negative 3. The next function picks up at the negative 3 and it stops at 2. So then we ask, is x allowed to be negative 3? Yes, x is greater than or equal to negative 3. So when x equals negative 3, I am going to use the blue function right here, because x can equal negative 3. So we're going to take our negative 3 and plug it into the x. So we're going to say 3 times negative 3 minus 1. So that gives us negative 10. Boom. Well, f is 0. So which value can I plug 0 into? Can I plug it into this first piece, the second piece, or the third piece? Well, x is less than negative 3. 0 is not less than negative 3. X is between negative 3 and 2. Hey, that's 0. 0 is between negative 3 and 2. So we can go ahead and plug it into this equation. So f of 0 equals 3 times 0 minus 1, which is negative 1. The next one says, well, what if f is 3? Well, looking at my pieces, we are told when x is greater than 2, use this bottom one. I did it in purple. So f of 3 means use the bottom one. Let me write better. So f of 3 is going to equal negative 4 times 3, which is negative 12. That's not so bad. What if f is negative 5? Also, I figure out where it is. F is negative 5. Well, I'm going to use the top one, because when x is less than negative 3, negative 5 is less than negative 3, this is the function I am going to use. So f of negative 5 equals negative 2 times negative 5. So that would be 10, that top one. Alrighty, so you take a shot at E, and we'll do E together in class. And then when, if you have any questions, let me know, and I will be glad to answer them. So I'll see you when I see you. Stay safe, everybody.